Good evening, everyone, and welcome to this session on AI, asset reliability, and discrete manufacturing. I'm Karthik Umachigi, senior analyst with ARC Advisory Group, and I'll be the moderator for this session. In this session, we have two distinguished speakers, each bringing their unique perspective and expertise. Our first presentation will be by Santrol, Analytics Practice Lead, Data and Analytics Group, Aditya Birla Group, who will be presenting on AI-powered asset reliability, a practitioner's guide to what actually works. And second presentation is by Harish P, Product Management Lead, and Abhishek Wani, Technical Team Lead, ACE Micromatic, presenting on AI adoption in discrete manufacturing and Indian context. So before we hear from our industry experts on AI-powered reliability and AI adoption in discrete manufacturing, I'd like to set the context for asset reliability and walk you through a brief introduction on what APM is. Asset performance management at ARC Advisory Group, it consists of five major classifications. I mean, it is classified under enterprise asset management, field service management, plant asset management, asset reliability software and services, and asset integrity management. So prior to this session, I mean, most of you might have heard, a lot of things about, and it sounds familiar. I'll just quickly walk you through on how we at ARC Advisory Group, we define each of the technologies. So enterprise asset management, it's basically maintaining all your maintenance work orders, labor resources, all those data which are all under the enterprise asset management umbrella. And next component is field service management, which basically helps organization plan, schedule, optimize, and perform services activities. Industries such as utilities, telecommunications, and service providers rely heavily on field service management capabilities, basically for route optimization, work order scheduling, inventory management, and customer engagement. Moving further, we have plant asset management, commonly referred as PAM. PAM solution focuses more on monitoring the asset and its health condition. It basically uses sensor, diagnostic, and condition monitoring technologies to monitor your asset and help identify potential failures before they occur. And another critical area is asset reliability and software service. Asset reliability software and services. These solution, as the name goes, it is mainly to have a maintenance strategy for your all the assets on shop floor and in and in a production environment. Mainly, it uses reliability-centered maintenance, failure mode analysis, and maintenance optimization program. They complement both condition monitoring technologies and EAM systems as well. We also have asset integrity management. It focuses mainly on assets operate safely and reliably throughout their life cycle while meeting regulatory, health, safety, and environmental requirements. This has been traditionally used in most asset intensive sectors, basically in process industries. And now I'll quickly walk you through about all the market trends that is shaping the market within the APM. And the first, we have enterprise asset management. So as you can see, we have agentic AI, autonomous asset management, generative AI, natural language interface, and sustainability embedded asset management. So prior to this, we see most of the speakers talking about the agentic AI, how it is being used. I mean, most of the end users are starting to have their own small language modules within their organization. And along with this, most of the enterprise asset management solution vendors, they are partnering with the major AI solutions provider so that all their end users get directly access to the agentic AI, and they also provide a low code and no code environment where the end users can train their agents. And next we see generative AI. I mean, users increasingly expect to interact with maintenance and asset management systems using conversational interface, reducing complexity and improve accessibility. So this is like more of, since when enterprise asset management, we have a lot of maintenance data, the maintenance engineer has to back and forth frequently access the data, and this is where the agents help and the generative AI helps in getting the relevant data on time. And next is sustainability embedded asset management, where organization integrate energy efficiency, emission reduction, and sustainability objectives. So these three major trends is what driving the EAM adoption within the industries. And next we have field service management. As you can see again, agentic AI and autonomous dispatch, predictive first service model, end-to-end platform consolidation. So these three are the major trends within FSM. Organizations are adopting predictive first service models. It enables maintenance activities before failures occur. At the same time, when autonomous dispatching and AI assisted scheduling are becoming increasingly important, and at the same time, vendors are moving towards broader end to end service platform that combine scheduling, workforce management, analytics, inventory, and customer interaction. For plant asset management, we see strong demand for cloud native and hybrid architectures. Smaller organizations and mid-market manufacturers are increasingly adopting these solution technologies due to lower deployment cost and improved return on investments. And moving to asset reliability software and services, the convergence of digital technologies and reliability engineering is creating new opportunities. One notable trend we see is like adoption of digital twins to support reliability centered maintenance and risk based inspection programs. Digital twins provide a dynamic overview of asset behavior, enabling more informed maintenance decisions. We also see ongoing platform consolidation through merger and acquisitions. So recently we have seen Autodesk has acquired MaintainX. MaintainX is also a core EAM vendor. Autodesk is a core design manufacturer. So basically we see a trend where platform vendors are trying to partner or acquire point solution providers, and that's how they're trying to enter the operation and maintenance domain. And next we have reliability as a service, where organization gain access to reliability expertise, analytics capabilities, and monitoring services through subscription based delivery models. In asset integrity, industries are shifting from time based inspection towards condition based inspection models. Advanced analytics and sensor technologies enable organization to inspect assets when condition warrants it, improving both safety and cost efficiency. Along with this, that's how they're trying to uh, be compliant with all the regulations. And next we have the buyer strategy. So as you can see, the prerequisite for all the buyers or who are evaluating the adoption of APM strategies, establishing data quality is a prerequisite. In order to have a data driven approach, you need to have a high quality data so that all your AI systems and other enterprise applications run smoothly and you have more visibility into the data. And the second is evaluate interoperability. Organizations should ensure their APM investments integrate effectively with existing EAM, CMMS systems, history, and operational systems rather than requiring disruptive replacement strategies. Third is we start with critical assets. A phased deployment tracking high value or high risk asset enables organization to demonstrate measurable measurable value quickly and build confidence for broader deployment. And the fourth is scrutinize AI claims. Given today's enthusiasm around AI, buyers should seek evidence of real world deployments and measurable business outcomes rather than solely relying on service providers' comments or demonstrations. Finally, we have focus on business outcomes. Successful APM initiatives are measured not by technology implementation alone, but by reduction in downtime, improvements in safety, lower maintenance cost, and stronger regulatory compliance. The key message is simple. Success in APM depends less on choosing the most advanced platform and more on executing the right priorities in the right sequence, starting with the data and ending with measurable outcomes. Thank you for your attention. I hope this introduction has provided useful context on the evolving asset performance management landscape and technology shaping the future.